over this worksheet here. And what's going on here? My screen seems to be frozen. There we go. Okay, so if we look at these two objects here, I kind of like to start down at the density one, but we can work our way around here. The easiest one to answer here is the volume, right? If we look at these two blocks, what's the story with the volume? Aaron, what do you have for this answer?
A is less than B.
Okay, and why did you say that?
The object is larger and has more mass.
Well, the object's larger, right? Period. End of story. Okay, got more volume. Okay, so B is larger. All right, for A and B, and when it comes to the mass, do they appear to be made of the same stuff? Yes, they do, because it looks like the same circles in each object. Okay. When it comes to the mass here, now what do you have? Okay, what was your reasoning there? Great. Got more particles. Awesome. All right, that makes sense, right? Got more stuff, more massive. Okay. All right, then for density, then, what do you guys have for density?
I think that we're equal because, the same area, like they're the same, even they're the same substance, then average, all densities are equal because of how many particles are in air inside body.
Okay. So that is good. So basically you're saying same particles in same amount of volume. Okay. Okay, so when I was going around and I would like cover up the screen, and it's kind of easier for me to do it like that, about like that, but it's kind of up there. So if we look at that, they look to be the same. We got about the same amount of particles and the same volume. So density is going to be equal. Okay. All right. So if we continue moving down here, we've got 3 blocks now. We're checking those guys out. Let's take a look at the volumes, because I feel like that one's the easiest one to start with, because it's real simple to do, right? All right. So Kyle, what you got here for the for volume for A and B, A and C?
I have B is larger than A.
Okay.
It's bigger, and then A and C were equal.
A and C are equal. Good. Okay. B is larger, and the same. Okay, that's easy enough to see, right? Same volume for A and C, and obviously A and C are both smaller than B. They occupy less space. Okay, that's easy enough. Okay, what about the masses here? So Nicole, what do you have for the masses, the relationships there? Good. And what is your reasoning for A and C? Okay, so very good. So B and C, it doesn't matter what block you look at, they both have more particles. Very good. More particles. All right. And then in terms of densities, Miranda, what'd you have for the densities for these guys? What'd you guys do? Okay, good. All right, so A and B is similar to the argument right up above, right? But what about A and C? Why'd you say that C is more dense than A? Okay. So you got more particles and the same volume. So they have to be more closely packed together, but you just have more in the same volume is what it boils down to, right? Okay, more particles in the same volume, got to be higher density. Okay, more stuff in the same space. All right. Flipping over to the next page. All right, so we got E and F. We got two different substances. Which one do you think has a higher density and why? So, Patrick, yeah. Okay, good. Particles are larger and take up more space. What I also say there, they're more closely packed together, right? So they're more closely packed. So there's less space because they take up more space, okay, between the particles. Good. All right, so we've got our, on the next one here, we're looking at the graph. Okay, we've got our graph, and we're looking at our balance, right, as well. So with these two substances, and as we look at these two, okay, so the first thing they asked us to do is start with our balance. Okay, we've got our two substances. They want us to start with the balance, and okay, if we put equal masses on the balance, what do we expect to happen? Oops. Stay there. There we go. Okay, put equal masses of A and B on the pan. So here we got A and B. We put equal masses on there. What do we expect to happen with the balance? Yeah. I would say no. Let's think about that a little bit more. Yes, sir.
Just feel like even like parallel to the ground because equal mass will put on all of the balance doing is weight.
Right. They're equal masses of A and B. It's the same mass. So the balance remains unchanged. Balance is going to stay straight. They're equal masses. That's all the balance is measuring. It's comparing mass between the two. Okay? If one is heavier than the other, the balance will tilt in whatever direction is heavier. Right? Whichever one's more massive, that's where the balance will tilt down to. Okay? But if you put the same mass on either balance, doesn't matter if you have a pound of feathers or a pound of bricks, they're the same mass. So you might need a lot more feathers, right? But you got same masses. Okay? All right, so what would happen if equal volumes were put on the pans? Yes, sir.
They would be unbalanced because like they never cross.
Okay, so it's going to be unbalanced. That's good. Which one will be, which one's heavier, A or B? Which one's heavier, A or B? Yeah, Miranda. And why do you say A? A has greater density. So more mass in same volume. Okay? A will have more mass in that same volume in comparison to B. I mean, that's kind of easy to see. Like, look, if we put 50 mils on the balance, right, we can just look at that line, go up. Okay, substance B is only going to weigh about 25 milliliters, or about 25 grams. Right, if we go up to right here, about 25 grams or so. So substance B is going to be 25 grams. Or if we have 50 milliliters of substance A, we're way up here at 100. Or I'm sorry, at 80. At 80, all the way up there at 80 grams. So substance A is more massive, even if it has the same volume. Okay? Okay. All right, good deal. All right, so move this over just a hair. All right, so for this one, find the density of substance A and substance B using the graph. All right, for this one here, some of you guys might have just taken some points and divided them. For this case, it would have worked, okay? But like if I give you data, right, like you've had in your lab, you need to draw a line of best fit. And what about that line of best fit is the density, slope. Okay, so in your labs, you guys gave me a trend line, and that's the density of your object, whether it was the apple or the water. Slope of that line is the line of best fit. Okay, so you want to use slope equals density. For this case here, it's really straightforward. Okay, they have great data, and it all runs right through here. And when they don't have any, like we don't have any like just points on the line or whatever, like we're drawing a line of best fit, is the line. Okay, so substance A turned out to be 1.6 grams per milliliter. Okay, and substance B is 0.5 grams per milliliter. Come on, there we go. Okay, so I'm just going to kind of cut to the chase. So typically you're going to take the slope, all right, and you're going to do that. So just like you did in your labs, that's what you're going to use for like a test. Okay, you need to use the slope to do density. You can't just average your data points. Okay, one of your data points is 0, 0. That line of best fit should be drawn through 0, 0. All right, so for C, okay, when you guys did C, this was kind of one of those things here. You're given information for A. So if you put 10 milliliters of A on one balance pan, what mass of B are you going to need to have for the other? Okay, in order for it to balance. So if it's balanced, what does that mean about the mass of A as compared to mass of B? Pans are balanced. Mass of A as compared to mass of B. Yes. They're the same. Okay, they're equal. So mass A equals mass of B. Right? Whoops, that's the wrong problem. That's no problem. I can just do that. There we go. Okay. So mass of A equals mass of B. So if that's the case, we just need to find out what the mass of A is. All right, so Cassie, how'd you guys solve this one?
For C, we use the graph on the bottom.
Okay.
Where it's 10 milliliters for substance A.
Mm-hmm.
We follow the line where it would equal the same amount of mass for substance B.
Okay. So you guys read the graph. That's a great approach. Anybody else read the graph? Good idea. Okay, yeah, you can read the graph, right, and estimate it, right? So if you had 10 milliliters of B, so it's right there, but you're reading up to A, so somewhere right in there. What'd you guys estimate it to be on the graph?
For substance B?
For substance, yeah.
We got
35 milliliters. I'm on C. Right, so 10 milliliters of A. I'm looking for mass of B. Oh, I gotcha. So you went like this. So 10 milliliters. So you went from here and then went over this way. I gotcha. There you go. So you went right here. About 30 milliliters. Okay. But it's still asking you guys. You're giving me a milliliter answer, and I want a mass answer. What mass of B is it? Okay, you're saying about 18. Okay. All right. That's fine. You can do it that way. All right. I just know E equals M over V, right? And I just plugged in. I know the density of A is 1.6 grams per milliliter. And I don't know the mass, but I do know the volume is 10.0 milliliters. So mass is equal to 16 grams. Okay, so I solved it mathematically. You could also, if you wanted to, you could have done it like by reading the graph too. Okay, you can do both of those. Right? I would let you know in the problem, like, hey, estimate by reading the graph what the, you know what I mean? I'll let you know specifically what I'm looking for, like on a test or quiz or something. Okay. All right. So for D here, if we put 35 mils of B in one balance, what volume of A would you need to put on the other? Okay. So the way I would do that is if I get 35 milliliters of B, so I got 0.5 grams per milliliter, I'm going to use D equals M over V, right? Because in order for it to balance, the same thing applies. I need the mass of A equals mass of B. So I need to know the mass of B, and I've got the volume's 35 milliliters. So mass of B equals, I got 5 grams. Okay, so in order to solve for volume of A, I got 1.6 grams per milliliter. I'm going to use another density problem there. 17.5 grams for volume. All V is equal to. So I ended up getting 10.9 milliliters. Okay, you could read the graph there again as well if you wanted to. That would work. Okay. Okay. Draw the line for density. This is one density. The one thing you're going to have to know is the density of water. Got to know that it's 1 gram per milliliter. Okay, density of water is 1 gram per milliliter. So if we were to draw that line, hopefully it looks something like this for you. Right? It's just drawn right up through here like this. So there we go. So we've got H2O right here. Substance A, substance B, water's right there, down the middle. Okay, so one of these substances is going to float, one of them's going to sink. Okay, one's going to float, one's going to sink here. So Sophia, what do you guys think here for when we compare A? Is A going to sink or float? Okay, and why did you say it was going to sink? More dense, right? Great. So substance B going to float, right? Less dense. Okay. All right, good deal. Any questions on that page? Okay. Keep on rolling. All right, for this one here, I'm just gonna. You guys had titanium, right? Copper and mercury looked at. So you had something. I'm just pulling an eyeball this here. I'm just gonna draw the lines on the graph. You should have 3 lines drawn on the graph, something like this, right? And I'm along those lines. Okay. Which one is up here? Which is the highest line? Can someone put them in order for me so we can label them? Rudolph? HD, copper, and titanium. Okay. All right. Good deal. All right. So for this here, you made some cubes out of each of the metals, except for mercury. Why can't we make a cube out of mercury? At room temperature. What's our problem, Pat? Yeah, it's a liquid at room temperature. So all the guys that are blue on the periodic table are liquids at room temperature. Okay, so that's kind of funky that mercury's I'm sure you guys have all seen mercury, liquid at room temperature. All right, so what's the volume of each cube? What's the volume for a cube? What is the formula for a volume for a cube? Length times width times height. Okay, so that means we got 2 times 2 times 2. 2 is 4 times 2 is 8. And remember, 1 centimeter cubed is equal to 1 milliliter. Okay, 1 centimeter cubed is equal to 1 milliliter. All right, so let's see. better than second period. During second period, every single group had a different answer. Different answers for these ones right here. Okay, so hopefully you came up with this 9.1 grams. Right, nickel was, what you guys have, 50 or 71.2. And then the last one was 57, is that right? No. Okay. You may have any questions? You want me to do one on? Yeah, absolutely. Absolutely. Okay, so for lead, right? The way I'm solving this, I'm doing D equals M over V, right? Okay. For lead, I know the density of lead is 11.35 grams per milliliter. Don't know the mass, but the volume is 8. We're thinking we got to find the mass of the following metal cubes. Okay, so we're using the metal cubes here. So 11.35 times 8 is going to give us 90.8 grams of mass. That should be, there we go. Okay, is that good? Yeah. Okay. And then you gotta change the density for each of the other ones. Okay. Remember that? Any questions? Okay. Yeah, what's up? Yeah, absolutely. Just plugging and chugging. All right, so the next question is very similar to when I give you the nuts and bolts, same deal, right? Use water displacement. Okay, just like the Archimedes principle stuff here, right? So we've got our mass of our gold coin, of our ring, check. And you put the ring in the grad cylinder. Initially, it's 42.2. You put the ring in there, then it's 43.7, right? So it's got a difference of 1.5 milliliters. That's the volume of our ring. Right, so D is equal to M over V. All right, so we've got 15.28 grams for 1.5 milliliters. So I got 10.2 grams per milliliter. Don't forget to have units on your numbers, okay? And I rounded that to 3 sig figs there, okay? 3 significant digits. All right. So is the ring actually gold? I don't know. Is it gold? What's our density of gold up here? 19.8? That's a big no. That's a big no. Right? Our density should be 19.8 if it was actually made of gold. Okay? All right. Okay, so E is the same thing, okay, except you're looking for mass. Right? They give you the density of the object. They tell you what the water displacement is, so the volume of the object, and you just solve for mass there. Okay. Our difference between those is what is that? 10.1. That's the volume of the object. We got the density of it right there. So D equals M over V. Plug it in. We got 2.99 grams per milliliter is equal to M divided by 10.1 milliliters. So M is equal to 30.2 grams. Yeah. I always want you to round it to 3 sig figs. Always. Yeah. Yeah, just get in the habit of doing that. All right, so we got iron wire, copper wire, titanium wire. We all got 10 grams of each wire. We got 10 grams of each wire. So which of the wires is going to be the longest? Which will be the shortest? Yeah. Great, and why are you saying that? I thought they're both, they weigh the same. They're 10 grams. There we go. So so do that again there. Okay, good. The density of titanium is less than copper. So more material, right? More volume is needed for, whoop, what did that do? For the same mass, right? Equals M over V. So yeah, that's one of those things. But when we're going through, we want to be careful with when we're talking about weight and stuff like that. Talk about density, all right? Because the masses are the same, the weights are the same there. Okay. All right. So for D, if every 1 centimeter length of the titanium wire has a mass of 0.15 grams, how long would the 10 grams of wire be? All right. I'm going to show you how I'm going to do this because I think a lot of you guys set up a proportion, which is fine, but I'm going to set it up so like the units cancel out and the units work so that I actually have a number at the end with a unit on it, okay? So you could set up a proportion like some of you guys probably did this, like 1 centimeter for 0.15 grams is equal to 10 grams for every X centimeters, like that. That's how most of you guys did it. I mean, you can do it that way. Yeah. Or people are looking at me like I'm crazy. And am I crazy? A little bit, I guess. I don't know. Okay. I'm going to do it this way. So if I got 10 grams of wire, I'm going to use that 15 grams and 1 centimeter as a conversion factor. So just like 12 inches in a foot or something like that. So in 0.15 grams, I've got 1.0 centimeters. So then my grams cancel out, and I'm left with an answer in centimeters. 66.7 centimeters. Okay. That's the length of our wire. Okay, sweet. All right, now this last one was a tough problem. It's great. Okay. It's a good problem here. So the diameter, I want to know what the diameter of the titanium wire is. Bless you. Okay. Some of you guys might have came up with 2.2 for the diameter of the wire, right? The 2.2 goes to about right there. That big. For the diameter. Not the length of the wire. We know the length of the wire is 67 centimeters. So basically from here to here, right? So that's the length of the wire. Some of you guys said that it's 2.2 centimeters in diameter. That's a really thick wire. Okay, a really thick wire. Right? So that really doesn't make a lot of sense. Okay, so when we set this up here, we need to know the volume of the wire. What is a wire shape, essentially? Cylinder, a really long, thin cylinder. Okay, it's really a long, thin cylinder. So when you type in, volume of cylinder into Google, it spit out to me pi r squared times height. Right? So I know that basically the length of my wire is the height of my cylinder. Okay, so I can plug that in there. I don't know the volume of my wire, and I don't know the radius, right? And the radius is what I need in order to find the diameter, right? Okay, so, but the best part is, I got D equals M over V, right? I can find the volume of my wire with density, okay? Because we know our wire is 10.0 grams, and we also know the density of the titanium is 4.54 grams per milliliter, or centimeter cubed. I'll do centimeter cubed here. Okay, so we can figure out what the volume is. So V is equal to, and and divided by 4.54. So I got 2.20 centimeters cubed. That's my volume. So then I can just plug that guy in right there. All right, and then we just kind of plug in and chug it. So I got two. I'll do it the long way here to just show you how the units cancel. Pi r squared, and we got 66.7 centimeters. So I'll divide each side by 66.7 centimeters. I mean, I'm going to do it the really long way. One of the centimeters cancels, so I have I got 0.0329 centimeters squared is equal to pi times r squared. Divide each side by pi. So pi's cancel. I got 0.0104 centimeters squared is equal to r squared. Now I can take the square root of both. Second square root, second answer. So I got 0.102 centimeters is equal to r. Multiply that by 2 to get me the diameter. And I got diameter is equal to 0.205 centimeters. That makes a little more sense. Still kind of a thick wire though. Okay. But not super thick, but it's going to be pretty thick. Got two of the little tiny hash marks on here. 0.2. All right. Still fairly thick though, compared to a normal wire. All right. Okay. All right. Questions, comments, concerns about anything on that worksheet? Nope. Okay.